Hi, my name is Tarek, and in this lecture, we will implement the insertion of operation of binary search tree. As you know, that the formation of binary search tree is something like on the left hand side of the tree is the lesser value. On the left hand side, we assign the lesser value, and on the right hand side of the parent or the root, we assign the greater value. So here, as you can see, we have two pans. I have a NetBeans IDE. You can use any IDE of your choice. And on my right hand side, on the right hand pan, I have the PowerPoint presentation, and I have three pointers here with the name blue is parent, gray is root, and gold is current. The golden color is the current pointer. How we can use these pointers, I will explain this in a bit. I'm using I have my own strategy of implementing insertion operation. You can use anyone. I'm using the iterative strategy for implementing binary search tree. So let's get started. I want to mention here that if any one of you is not comfortable with references and pointers, so I will highly recommend you to first refresh and read how the references are managed or can be managed and how the pointers work. If any one of you have implemented linked list on your own, not the one which is provided by Java or any other library, then this lecture will be very easy for you to understand because we will use pointers and references, and binary search tree is all about pointers. If any one of you is not comfortable with that, so please refresh those and then come back. And if you are confident, then it is good to go. So now let's declare a node class. So I am creating a node class inside the binary search tree because there is no need for declaring it outside the binary search tree as a new file. It's only related to this class. So we have three data here, three data members here. One is data, and one is the left node. We have a ref. We will keep the reference for the left node, and we will also keep the reference for the right node. And let's create a simple constructor here, and that constructor will be having int data, and what we will do, this dot data, the current reference will be equal to data. Okay, and what we will do is left this dot, we can simply say left is equals to null. The left will be null and right will also be null. Okay, so we are declaring these two references initially as null, right? So this is a node class, and we will use this node class in our binary search tree. So now what the next step is? The next step is to declare the root node. So let's declare the root node. Big static root. Sorry. Node root. Okay. And now we have declared the root node. Let's declare the constructor, and this dot root is equals to null right now. Okay, now the game starts. Public void insert, and we will take the numerical value from the user. And now here in the PowerPoint, let me share some values. So let me declare three values: 10, 5, and 15. This is because I want you to understand my code, and I would also use these pointers so that you could understand how these pointers will be helpful in creating the binary search tree. So the very first step in the binary search tree is to create the root node, right? To create the root node, and the root node will be of value 10. So this will be of value 10, right? Now coming back to the code, what we will do is we'll create a node, new node is equals to new node, and this will be the id. So when we will call this method, we will pass 10 from the calling side, and we will check if root, right, if root is equals to null, it means there is no root available right now. There is no tree. So what we will do is we will say root is equals to new node, right? So we are assigning this new node to the root node, right? And then we will simply return from here. So it means now we have the root node available, right? And now the next value, based on the next value, we will decide should the next value be is lesser or greater, and then we will move that to the left or the right hand side. Now I have two pointers, node current, sorry, double RENT, current, which I am assigning it to the root node, and I have another pointer which is parent, which I will assign null at this point. Now I have while method, and I'm saying while equals to true. So it's an infinite method, and so as I told you, I'm using the iterative strategy here. So what I'm saying now, I'll say parent is equals to current. I'm giving the reference of current to the parent. So right now, what's happening is, now let's look at this presentation here. So right now what I did is, at this line, I've given the reference of root to the current. So this current, the current pointer is now referencing or pointing towards the root, right? And in the while section, I have given the reference of current to the parent. So now parent is also pointing to the root node, right? And root node, as you can see, the root node is actually pointing towards the root. So this is actually the root which will remain here. Now let's coming back to the code, and now I will check if id is less than current dot data, right? So what I'm saying is, if the value is less than the root, right? If the value is less than the root, so what you will do, you will do current. Now make the current, or dereference the current to the left hand side. What I'll say, current dot left, right? So now what I'm saying is, let's say we have a value, we have a next value here, right? So the next value is 5, right? Next value is 5. So now what I'm saying is current, right? Current dot left, dereference or give the reference of the left side to the current. So now what I'm saying is here the left and the right both are right now, both are what? Both are null, right? Left and right both are null. And what I'm saying, that if id is less than the current data, then pointer the current dot left should be the current one. So this is something like this, right? So the current pointer is now actually pointing to the left of its side, right? It's actually pointing to the left of its side. Now coming back to the code, and now here I will check if current equals null. If it is null, in this case we have the value is null. So what I'm saying is parent dot left is equals to new node, right? Now it means that parent dot left, this is parent, right? And this is its left. Now assign the new node assign the reference of the new node to the parent, right? So the new node is 5. So now this will be 5. And as you can see, the pointer current is actually referencing to pointer 5, right? To the node 5, right? According to the code. Coming back to the code. And then here our work has completed. So we will say return. We will say return. Okay. Now in the next case, we have else, and we know else if the value is greater. Here we was checking for the lesser, if the id is less than data, and we know in the else section we want to code for the if the value is greater than the current data. So what we will say current equals to current dot data. We will get the data, and we will check if the id, right, whatever the value you have given, if the id is greater than, or I think we need not to check this, we need not to have this checking here, because we know the value is actually greater. So we just need to check if current is equals to null, right? If it's equals to null, so as here, and here you can say, I think I have made a mistake. It should be current dot right, right? So now if if the current is, if the value is less, then the pointer will come here. Otherwise this pointer is here, and the value is greater, which is 15, and if it's greater, then this pointer will come here. It will point towards here. And right now the current value of the left hand side of the right hand side of the root is null, right? So if the value is null, coming back to the code, if the value is null, so what we will do, I will do parent dot right is equals to new node. I am assigning the new node to the right of the parent, right? So it will be something like, now this is no more null, and this section will have 15, right? This section will have 15, and then coming back to the code, and then we will say return, then we will say return, right? So this is the insertion operation for the balance, sorry, for the binary search tree. So in this lecture, my focus here is just to implement the insertion operation, and in the next lecture we will insert some values, and I will show you how these pointers that I've just shown, how they are working, and we will insert some series of values, some 8, 9 or 10 set of values, and we will form a binary tree, and we will also see how these pointers can be helpful for us. If you haven't understood anything, repeat these video for as many times as you like to understand, and hopefully you will get this point.